All right, so when solving each of these, remember that since these have both the x squared and the x, we're going to want to start each of these by factoring them. So for number 1, our factored form ends up being x plus 5 times x minus 3 equals 0. Remember to still include that equals 0 there. A lot of people tend to drop it out. That'll cause you problems later if you do, though. Because then we are saying what plus 5 equals 0 and what minus 3 equals 0. Ends up being negative 5 and 3. When you write it out, please also include the x equals on that, because getting answers, just a couple numbers written at the bottom, we can kind of figure it out what you're meaning by that, but if you say x equals, it's actually saying what you mean it to say. Number 2, we need to factor that one now. Can we factor the 5 out of every term on this one? No. That means you've got to go to box method. So you go to box method. And that's what it ends up looking like when you find the correct combination. And so we end up with a factored form here of 0 equals 5x plus 1 times x minus 7. And then in order to solve it, we're saying what, again, makes each of these parentheses equal 0. So the x minus 7, okay, that one's straightforward, hopefully. That would give us 7. The 5x plus 1, that one takes a little bit more work. So in order to solve that, write it out as an equation. 5x plus 1 equals 0, and solve it. So you'd subtract 1 from both sides and then divide by 5. It ends up giving you negative 1/5, or negative 0.2 if you gave it as a decimal. And so again, we're getting that number by taking 5x plus 1 and setting it equal to 0 and solving that. And then for number 3, can I divide everything through by the negative 2? No. So then, that tells us to go to box method. And on this one, I actually want to take a closer look at it here. So in order to get the negative 2x squared, we do negative 2x and x. In order to get the 5, there's only one way to get 5, thankfully, and that's 5 and 1. So the only question is it going to be 5 and 1, or am I going to have to switch that order? So we try this. 5 times x gives me 5x. Negative 2x times 1 gives me negative 2x. Do those add to 7x? No, they don't. Okay, so then we try switching it. And so that gives us x and a negative 10x. Does that add to 7 then? No. And that's the only way we can get the 5, and that's the only way we can get the negative 2x squared. So then that means this one is not factorable. But it can be solved, and that's what today is going to be about, is how do we solve it if it's not factorable then? And so we got to start with some notes. We're going to be using the quadratic formula today. Please add the formula and some of that vocabulary that's underlined to your math notes. In your notes now that you've written all this stuff down, please take a moment, make sure you've written down the formula correctly. Check the signs and everything else in particular, because it can be very easy to drop a negative or something like that, and if so, it's going to cause you a lot of problems for a while until you realize what happened in your notes. Notice it's a negative b. We got that plus or minus symbol, which means we're going to end up doing this once with the plus and once with the minus, of course. Then inside the square root is all of b squared minus 4ac, and make sure that when you write the fraction line that everything is over 2a. Now, you are going to need to have this formula memorized. It won't take too long for you to get it memorized, because some of you have even seen it before, and even if you haven't, you're going to be using it enough where it's just going to become very familiar. Plus, you'll notice that within this formula, there's actually something fairly familiar. Remember the formula for finding the x-coordinate of a vertex? Negative b over 2a? That's part of it. It's actually part of how this happens. So if you really want to kind of challenge yourself in thinking about it, you can be thinking then, okay, well then what would this mean in terms of the actual graph? It's something interesting you can think about it going forward. All right, now we're going to be practicing using this formula. And the best place to start practicing it is with that question that we could not factor earlier. So we're going to solve this using quadratic formula. First thing we have to do when using quadratic formula, since we're going to be plugging in these a, b, and c values, is figure out what is a, b, and c. So what is the value of a in this particular equation? It is the -2, yes. Notice it's just the -2. A is the number that's being multiplied by x squared. It does not include the x squared. So a is going to be -2. B is what's multiplied by x. In this case, that's 7, a positive 7. If this was minus 7x, b would be a -7. And then finally c. C is whatever number is added or subtracted onto the end. So in this case, c is going to be a positive 5. Again, if it was minus 5 hanging on the end, then c would be a -5. Now that we know a, b, and c, please plug those values into the quadratic formula for this problem. All right, let's check and see how well you've done plugging those numbers into the equation. This is what it should look like there on the left side when you plug in the values for a, b, and c. And then having plugged those in, now we're going to actually have to evaluate this. Now we actually have to do the work. So let's start simplifying everything we can. So we got a -7 out front. Plus or minus stays plus or minus. We don't do anything with the plus or minus till the very end. Then inside the square root, we got 7 squared, so I'm going to turn that into a 49, minus 4 times -2 times 5. I go ahead and do this multiplication all at once. So 4 times -2 is a -8. -8 times 5 is -40. And so, now notice though, when we do this, we get -7 plus or minus 49 minus a -40. What's minus a -40 become? Positive 40. Many of you will jump straight to writing it as plus 40. I try to write out as minus a negative first because it helps avoid any potential little errors that might crop up along the way. So if you're thinking, wait, isn't that going to be positive? Yes, it ends up being positive. The caution with that, though, is, and this is something that happens with a lot of people if we get, usually after we've done like half a dozen of these, some of you will look at this and you'll look at it as multiplying by a -4. And so you'll multiply the -4 times -2 times 5, and you'll say, okay, that gave me 40. But then you'll still write the minus, even though you just used it by putting it in as a -4. My suggestion then, leave this as a minus, and instead of multiplying by -4, just multiply by 4. That way you remember that this minus is a minus here. Then you can worry about the minus and negative after that. It helps prevent some errors that tend to crop up. All right, then we can go ahead and keep working through here. So we end up with x equals -7 plus or minus the square root of 89 over a -4. Now at this point, we need to know what to do now. If this problem said, give your answer in exact form, or in simplified radical form, or something like that, we'd be done at this point. That would actually be the answer. Because exact form means we're leaving it in terms of the square root. But this one doesn't say leave it in exact form. It says round to the 100th. That tells us give the answer as a decimal, which means we're going to have to break out the calculators on this one. So, calculators out, and let's see how we actually do this calculation. So when doing this calculation, the biggest suggestion I can give to you is calculate the top value first. and then divide it by the -4. If you try to kind of do it all at once, it ends up being a problem. Now, the nice part is if you're working on a graphing calculator, you can actually just type it in as you see it. So for the first answer, what you would type in is you'd do -7 plus the square root of 89. Notice I'm just writing plus right now because we have to do it once with plus, and then we're going to come back and do it again with the minus. So on a graphing calculator, it's nice and easy. You get that value, press enter, press equals at that point. Then, after you have that number, then say divide it by -4. If you're doing it on a non-graphing calculator, you're still going to do it the same way, where you're going to figure out what the top value is, and then after you have that number, divide it. And so you're doing it once with the plus, and you're doing it once again with the minus. Same order. So for our answers here, the very first one, when we do the addition, you should be getting an answer of -0.61. Notice I'm rounding it to 2 decimals here because it said to round to the nearest hundredth. So that's telling me what to round to. And then when you do the subtraction one, you should be getting an answer there of a positive 4.11. And if you're getting those numbers out right, you know you're doing it correctly. And if not, well, that'd be a great thing to ask about here. Sometimes the toughest part about these is actually doing the calculation. We're going to be practicing the calculation side of things a little bit tomorrow as well. But for now, let's take a look at just using the formula a little bit more with one last practice problem. This last one, it's not going to say to round your answer. This last one, we're going to be leaving our answer in exact radical form. When you see the words round your answer to this, it's telling you give your answer as a decimal, so break out the calculator. When it says exact or radical, when you see those two words in there, that's telling you just leave it in terms of the square root. So you can leave it as that number plus or minus square root kind of a thing. And so here's the last one that we're doing together. Write down this problem and use the quadratic formula to solve it out. So check to make sure that you plugged everything in correctly. That's what you should have at the start. And so when you actually do the simplifying of the numbers, you should be ending up with the 12 plus or minus, and then inside the square root just becomes a positive 32. And it's all over 8 here. Now, having done that part, we actually can simplify this a little bit more. And so kind of a little bit newer kind of stuff is a chance for us to take a look at how would we simplify that. So let's simplify the root 32. What's the biggest perfect square that goes into 32? 16. And the square root of 16 is 4. 16 times 2 is 32, so it becomes 4 root 2 over 8 still. Now this can even simplify a little bit further in this particular case. In order to reduce the fraction, we have to be able to divide everything on the top and the bottom by the same number. Now when we look at that, we're looking at 12 and 8 here. Those are whole numbers outside of a radical. So I couldn't be looking at the root 32. I have to be looking at the number that got pulled outside. So the 2 that's left inside the radical doesn't change anything. So what can I divide 12, 4, and 8 all by? 2, yes. 4 is better. So we're going to now divide all of them by 4, which gives us 3 plus or minus root 2 over 2. And that is the simplified exact form. Now notice why this is called exact form. It's exact because you can put this in your calculator and get the whole decimal. But if you gave your answer as a decimal, you wouldn't be able to write down every possible decimal because these are decimals that go on forever and never repeat themselves. So, exact form, leave it in terms of the square root.